Hello, in this video, I'm going to show you how to do statistical analysis of the stat sample data that you collect for the project. In the previous two videos, I have shown you how to summarize categorical data in bar graph using StatCrunch, and also summarize the one of the quantitative data in a histogram. At the same time, we also calculate numerical summary, meaning X bar, standard deviation S, and also sample size. And we have two samples. So the population one is college students. Population two is non-college students. We also created scatter plot for the two samples for a pairs of quantitative data of stay home time versus predicted lifted time. I think I should say lifted time here. How long do you think that shelter in place will be lifted in California? And it seems like that there is both of them. There's no correlation except for the non-college adults data sets, match pair data set. The correlations seems to be higher. So I want to do a correlation analysis of this one to see if there is actually a correlation between stay home time and predicted lifted time. So namely, we'll do three things. First, confidence intervals of the categorical proportion. Second, hypothesis test for stay home length, which population stay home longer, and linear correlation test for non-college adults, whether the stay home duration and predicted shelter in place lifted time are correlated. So from the last videos, we actually have summarized the data in X and N for proportion. So the proportion that we are counting is people that are strongly affected in both populations. So population 1, I have X1 equal to 8, N1 equal to 28. Population 2, I have X2 equal to 6, N2 equal to 22, as shown in the last video. So we are ready to do our hypothesis or our confidence intervals. So to do that, I will go to StatCrunch. You can start a new StatCrunch table because you don't need to use those data. You summarize them already. To do confidence interval for two proportion, you do proportion stat two sample with summary because you actually have summarized them. So in our case, our X1 is 8, N1 is 28, X2 is 6, N2 is 22. And then we want to do a confidence interval. So in our case, we just do a 95% confidence interval, and that's the output. Okay, so I'm going to screen print it. I'm going to include it in the appendix so that it shows my calculation. Okay, so just put it in here, appendix. And in particular, I want to write down the two upper limit and lower limit is negative 0.237 and 0.263 of P1 minus P2. So I'll go back up to my report under statistical analysis. I now have, you will document it, is I use StatCrunch, proportion stat, to sample with summary. And my output is negative 0.237 P1 minus P2 0.263. And then you can do a conclusion. So that means we are 95% confident that the difference in percentage of people strongly affected, because we're counting strongly affected by COVID-19, is between college students and non-college adults is between from negative 23.7% to 26.3%. Since the interval contains 0, we conclude that there is no significant difference in percentage of people strongly affected by COVID-19 for college and non-college adults. So that's how my conclusion would be. And then the next we would do a hypothesis test for the number of stay-home days between college students and non-college adults. Our summaries are written here. So what we do is we'll just do our summarization here from StatCrunch. So enter these into StatCrunch and do it. And we will want to do a so we're done with this. Want to do a t-stat and two sample tests. They're not matched pair data. They're just two sample from two populations. So we'll just do a t-stat, two sample with summary. We could do data, but we just don't want to move them around. They're in two different files. So my x1 bar or x1 bar 3.9. Standard deviation is 2.3. You want to be more accurate, you can do more decimal places. 2.9 here and 22. And we don't put a variance because sigma is unknown and we assume to be unequal. Oh, what should our claim be? We haven't set up our claim, so let's go back and do it. So what should our claim be? Before we do it, we should say claim. In my project plan, I say that the college students should stay longer, right? So actually it's contrary in the sample. College students mean bar, the sample mean actually is smaller, but I need to follow my claim. So claim that, okay, so maybe I'll write my claim here. It's college to test the claim that, to test the claim that college students stay home longer. So college student is a population 1, so it'd be mu1, right? So mu1 greater than, mu1 greater than mu2. That's my claim. And then I will set up x0 will be mu1 equal to mu2 by default, or null hypothesis should be equal, that they are temporarily assume that they're the same. And h1 would be mu1 greater than mu2, and in this case, my claim is in h1. And then we will continue to do my tests, right? So go back to here. Then I would say it's greater. Okay, it's a right-tail test, and I would do compile. So this is my output. Again, I screen print it so that I have a record of what my output is supposed to be. Did I double check? So put it in appendix again. So did I enter it wrong correctly? 3.9, 2.3, 28, 4.7, 2.9, 22. Yes. And that is what I did when I enter it. And my test statistic was, what was it? I forgot to write down. Negative 1.06.8519. So it's a very low test statistics. So output use StatCrunch, tstat, to sample with summary. So we enter the summary. The output is t is equal to negative 1.06. P-value is equal to 0.8519. So our initial conclusion will be 0.8519. The p-value is greater than 0.05. Use our default significant value of 0.05. So fail to reject, X0. So the conclusion is there is not sufficient evidence to support the claim that college students stay home longer than non-college students during the shelter in place. Okay, so there's and so this is claim was not being supported. The third one is to test for linear correlations. In the non-college adults stay-home data, we want to look at if stay-home duration and predicted shelter-in-place lifted time are linearly related. Because in our scatter plot, it seems like it has a higher R compared to the other one. So I'll go back to my StatCrunch data, and I want to look at the non-college student data sets. And to study correlation, we use stat, regression, simple linear. And then we would do a stay home time and lifted time. And keep these the same, keep these default, and then we do a simple linear regression results. So I'm gonna cut and paste this, also screen print it, so I can save it in appendix. Copy. We already have the scatter plot, so I don't think we need to do the scatter plot screen print. So just this one. So screen print the third statistical analysis, place it here. And then we need to write down what the result is. The result is t equal to 1.51. P-value is 0.146. Okay, so go back to our write-up. Okay, so we will just use StatCrunch, regression, simple linear for the non-college student, the non-college adults data sets. Okay, so the result is t equal to 1.51, p-value equal to 0.146. So here I did not talk about what my significant level is. Maybe I'll just use this default significant level equal to 0.05. So, and then I'm going to do the, to do this, actually, I should write up the null hypothesis, right? So X0 would be rho. You should write it down. Rho, symbol rho is equal to 0. So assume no correlation. H1 is rho not equal to 0. Okay, not equal to 0. And then obviously the results show that 0.146 is greater than 0.05. So fail to reject. X0. So conclude no correlation. No linear correlation. So you can write down that there's